CRT class 9, chapter number 2 is matter around us pure. Children, after learning in detail about matter in the first chapter, now we are going to discuss with the second chapter, that is what is matter around us pure. When we hear this sentence, a question will arise in our mind, children. In the first chapter, we came to know that everything which exists in the universe, if it have a mass and space, means if it contains mass, if it occupies space, then such a thing we call it as a what? Matter. So, such a matter, whether it is pure or not, going to study in this chapter. Is it clear, children? The main theme of this chapter is we are going to understand if matter is present everywhere. So, if it is in the pure form or impure form, and different things we are going to discuss under this chapter, children. So, what are the main topics which we are going to discuss here? Or the first and foremost, what we will do? We will go with the learning about introduction of the pure form of a matter. Then next we have what? Mixture and its type. Here we are going to study homogeneous and a heterogeneous mixture and the definitions of a mixture and its types we are coming to learn. Then after that we are moving with the solution, suspension and a colloidal solution or colloidal. And next we have what? The methods of a removal of a or separation of a components from a mixture. Different methods we have, children. I hope in our low classes we studied sieving method, isn't it, children? If the objects or components are present, if they are visible to our naked eyes, means we will go physical methods. The best example is what? Sieving method. So like that we have different separating techniques like filtration, isn't it, children? Then fractional distillation and separation of immiscible liquids, miscible liquids, all such things we are going to learn, children, along with important concepts like centrifugation and chromatography we are going to coming across here. Then next we have what? Physical and chemical change. What is mean by physical change and what are chemical changes and what the things we are going to get, such all things we are learning under here. And the next one, the last topic of this chapter is what here? Types of pure substance. Mainly we are discussing here what? That is pure substances and a mixture. Under the pure substance we are coming across what here? Elements and a compounds. And the next one, in the mixtures we are discussing about homogeneous and a heterogeneous mixture. Is it clear, children? What are the main concepts we are learning in this chapter? Yes, very good. Now we will go what? One by one in detail. Children, now we will discuss pure substance means what. In our daily life, in so many things, we are coming across with the term called pure. What is the meaning of a pure here, children? If it doesn't contains any other than that or any impurities, any adulteration, then it is said to be what here? Pure. For example, if the biscuits or oil or any milk, if we brought from the grocery shop, the word agmark or the term pure will be written on it. By seeing that, we will come to know that it is a purest form of that given substance. Isn't it, children? We will come to know that by knowing the term pure upon these packets, we will conclude that it is a what? Purest form of the substance. So, this pure substance is not going to be actually pure for a scientist. Let us take one example, children, better. That is, for a common person, means we all, whatever the pure substance is there, means it should not contain any adulterations, not contain any impurities. then it is said to be what? Pure. But for the scientist, it is different, children, isn't it? That is, example, let us take a milk. If the broad milk is pure for a common person, and in what means it is a pure? If it doesn't contains any other powders like tea powder or sugar or any wheat flour in that, then it is called to be a pure for a common person. But this pure milk, now it is not going to be a pure for the scientist term, because the milk contains so many things in that. But for a scientist, now this milk is not to be a pure, because it contains water, it contains fats, isn't it, children? It contains proteins, like this, carbohydrates, glucose, so many things will be present in the milk. So because of these different components, now the milk is what? Not a pure according to the scientist. So how can we define the term pure substance, children? A pure substance is a one if it is constituted by a single type of a matter. What is that? A substance is said to be pure if it consists single type of matter. Isn't it, children? Because here for a common person it is a milk, isn't it? But for the scientist, so many things are present, more than one different particles are present, matter is present, substance is present, so it is not a pure for the scientist. In other words, we can say that a substance is pure if it contains a single form of a matter, and such a formed substance for a common person is consist of, it may contain many things, and also for the scientist, the chemical nature of that substance is what? Different, isn't it, children? So by this way we can define what? Pure substance. A pure substance is a one, it should contain a single type of matter in it, single type of pure substance, that is matter. If it contains, then we will say it as a word here, pure substance. And depending upon this constitution, we have what? Next, mixture. After learning or understanding the concept pure substance, now what we have? Mixture. Pure substance means it should contain a single type of matter. Then what is mean by mixture? A mixture is constituted by more than one pure form of a matter, isn't it? It is, a mixture is a one which is constituted by more than one form of matter. Then it is said to be what? Mixture. For example, children, for what things we can say it is a mixture? Let us take examples. Water plus salt, isn't it? It is also what? Mixture. Because it doesn't contain only one substance, it contains more than that. Then we can call it as a what? Mixture. Similarly, you can take, that is cool drinks, aerated drinks. Aerated drinks. It is also what? Mixture. And also, children, soil. It is also word here mixture. And why so all these children while eating the snacks we will come across with the mixture. What it does, it contains children? It contains saves, it contains peanuts, it contains what? Poem, means all these different. It consists of a more than one form of a matter. Then such a thing is called what here? Mixture. Is it clear, children? Okay, once again I'll repeat. A mixture is a one. It consists of more than one type of a pure form of a matter. Isn't it? Next, examples what can we give? That is aerated drinks, soil, sodium chloride, water, salt. These are all what? Different examples of a mixture. Depending upon the type of the or the composition of the components, we have what? Two types of a mixture. What are those, children? Homogeneous and a heterogeneous mixture. Now we'll discuss types of mixture. As I told children earlier, depending upon the nature of the components that form a mixture, we have broadly two types of a mixture. That is homogeneous mixture, and the second one is what? Heterogeneous mixture. Mixture. Is it, children? What are the types of mixture? Homogeneous mixture and a heterogeneous mixture. Sorry. Now we will discuss what is this homogeneous mixture. Sorry, children. Suppose if a given mixture contains uniform composition throughout, then such a thing is called what here? Homogeneous mixture. Let us understand this definition by taking an example, children. Suppose if I take a test tube, isn't it? If we pour water into that, if we add, what is this? This is water. If we add a salt or sugar, then after stirring it well, what happens? Whatever the water it has present earlier, now it gives rise to what? Salt water. Means all the particles of the salt are going to distribute or going to dissolve completely, evenly in this water. Means if you take top of the water, now here also it contains salt particles. Now you take the bottom of the water, here also you will get a salt particles. Means if the composition is uniform throughout the mixture, then it is said to be homogeneous mixture. So how can we write definition, children? That is, it is a type of a mixture if it is constituted by uniform composition. Means it is going to distribute uniformly in the mixture. Such as mixtures are called as a homogeneous mixture, and you can take even sugar solution also. It is also going to dissolve, isn't it, children? If it completely dissolves in the given solution, distribution is going to be equal in all the way, by all the means. If it is equal, then it is said to be what? Homogeneous mixture. Suppose heterogeneous mixture means what? Let us take, that is soil, children. If this soil is poured into a test tube containing, what happens? The salt particles are going to be settled only at the bottom of this test tube. Whatever the water which is present here, it may or may not contain the soil particles, but these heavy soil particles are going to settle down. If you take this, that is bottom water, then you will get a more amount of a soil in that. Suppose if you take top of the test tube water, you will get a less amount of a soil in that. So what is the meaning of a heterogeneous mixture, children? If it contains non-uniform composition, then it is called a what? Heterogeneous mixture. Means the given substances, if they are not going to dissolve completely, if they are distributing unequally, non-uniform composition, then it is said to be what? Heterogeneous mixture. Even you can take iron fillings also, children. If you pour iron fillings to this water, what happens? They are also going to settle down, isn't it? Iron fillings you can take. Then you can pour oil also. What happens? This oil is quantity is going to be float on the surface of the water. Means the oil particles are going to be more in the top of the water, whereas bottom you may get less in amount or not at all. So these are all what? An example of a heterogeneous mixture. So what can we write the definition, children? Non-uniform composition. Non-uniform composition, then we will call it as a what? Heterogeneous mixture. Is it the concepts are clear, children? That is types of mixture. We are coming with two types. What is that? Homogeneous mixture and a heterogeneous mixture. If the composition is uniform throughout the mixture, then we will call it as a homogeneous. If it doesn't contain, means non-uniform composition, we will call it what here? Heterogeneous mixture. Children, now we will make a small activity in order to understand the given mixtures, what it consists of or what is going to be formed. Means it might be in the form of a solution or suspension or colloidal. So for which one we have to say solution and for which one we'll say suspension and colloidal, we will learn by making this activity. This is what? Activity number 1. Let us divide a classroom of people, that is students, into 4 groups, children. Let us divide the classroom into 4 groups. How many groups we are making, children? 4 groups. We will name them as group A, group B, sorry, group C and group D. Isn't it? This classroom of children we have divided into 4 groups. And let us give for the group A members, that is crystals of few crystals of copper sulfate. And for the group B, we will give a spatula of one full spatula of copper sulfate. Then for the group C, we will give, that is wheat flour, isn't it? Or chalk piece powder you can give, we can take. Then for the group D member, we will give a few drops of ink. Isn't it, children? Now this is what at the very first step. For 4 group members, we have given different things. What all the things or ingredients we have given, children? For the group A members, we have given crystals of a copper sulfate. For the group B members, a spatula of a copper sulfate we have given. For group C, wheat powder, or that is flour or chalk piece powder you can give. Then for the group D, we can take that is what? A few drops of ink we can use. And we have to ask them to add a water to all of these ingredients. Means let us add water to this, and also for this a small amount of water is going to be added equally to the separate all these four that is the test tubes, that is water, and we had to ask them stir clearly with the glass rod. By using a glass rod, we had to ask them mixture, what we have to mix it. What we are going to do, we are taking a water and adding a free crystals of a copper sulfate for the group A member, and for the group B member we are asking them to stir a spatula of a copper sulfate, 1 spoonful of copper sulfate to the water, and for the group C, wheat flour or chickpeas powder we can add to the water, and group D, few drops of ink is added to the water, and we have to ask them observe carefully, isn't it? And also we have to ask them to pass a beam of a light. Beam of a light means here a rays of a, generally more than one ray, we will call it as a beam. A collection of a rays of a light, we will call it as a beam. When you pass a beam of a light, we have to ask them in which solution the path of the light is going to be visible, isn't it, children? So by doing all these things, it has been experimentally found that group A and group B formed a solution. Means these two test tubes, whatever the ingredients it contains, had mixed in the water and formed into what? Solution. Whereas this wheat flour or chickpeas powder is not going to mix well with the water, and it formed into suspension. Whereas the few drops of ink completely mixed with the water, and here when you pass a beam of a light to this, the particles are what? That is you can observe the path of the light here. So it is called as a colloidal solution. What is this? Colloidal solution. Because it contains the particles, because of this presence of particles, what happened? The path of the light is going to be formed. Scattering of light is occurring in the fourth one. Means in the group D, the path of the light is going to be visible because of colloidal particles. Is it clear, children?